Good afternoon, ladies and gentlemen. Thank you for coming to this session in which I will tell you about the most dramatic change in networking in a generation. For those of you that are under 30 years old, you were not born when the previous revolution in networking occurred, but you're here now for this one. I am delighted to be here in Japan. It's my third time here in 7 months because Japan is the most exciting place for OpenFlow and SDN on the planet right now. What I will share with you today are these things. Really, what is software-defined networking? And what is OpenFlow? How are they different? And how do they relate? And where did they come from? I will explain why the industry is so interested in these changes in networking and what the Open Networking Foundation is doing to bring about these changes and put the benefits of this revolution in the hands of those who operate and use networks. There is not a network in the world that will not be affected by these changes. And finally, I will talk a little bit about our plans, the work we are doing and planning, and about the community that is actually doing the work and making it happen. And I'm very pleased to have two of my colleagues today join me briefly during this presentation to share with you their perspectives. Software-defined networking is more than OpenFlow, but OpenFlow is an important part of software-defined networking. Those who operate networks, either in the public domain as service providers or in the private domain as enterprises, have long suffered inflexibility in the network and difficulty in getting the network to do what they want it to do. And for these difficulties, they've paid high prices. There are many communities in the networking world that have their own requirements. I've only shown 4 broad categories here, but they are only 4 of many. Certainly, it is the telecom service providers and the hyperscale data center operators that are driving this revolution and adopting it first, but they will not be the last. The service providers are facing a crisis in making their revenues match their costs. All of us in the room are responsible for the growth in bandwidth that they are having to provide while we refuse to pay any more than we already pay. The service providers want to expand their businesses. They want to offer new services to enterprises and consumers. They want to do this quickly. They want to experiment. But up till now, they have been unable to do so because changes in the network take a long time to go through a standardization process and then implementation in proprietary systems by vendors. The hyperscale data center operators have made amazing strides with off-the-shelf hardware and software in the computing domain. Look at Google and Facebook and Amazon. But they have not been able to do this in the networking domain. They virtualize the computing, but not the network. They're spending more on capacity than they need to and can afford to. They have come to us for solutions. Enterprises, especially medium-sized and small ones, would really like to get out of the business of having their own IT organizations and be comfortable outsourcing it to a cloud provider. But they want to feel that they have control over their virtual resources. They have not had the tools to do this until now. It is software-defined networking that gives the abstraction and virtualization that make remote control of virtual resources possible. And it is the OpenFlow protocol that enables logically centralized control, giving application programming interfaces for direct programming of what the network does for the first time ever. There are a number of technology trends that have made this feasible now. I show some of them on this slide. Networking devices now typically have a lot of custom silicon. More and more, they want to use what we call merchant silicon, standard chips for networking that are low cost and high performance and mass market. Traditionally, they've had hardware-based appliances. You take one box, you put it in the network to do one function. It's expensive and inflexible. We can now do that with open software that can run anywhere on ordinary servers, running ordinary operating systems, and programmed using ordinary languages. Since the advent of the Cold War, the Internet has been designed around a philosophy of distributed control, where every autonomous system has all the information it needs to determine where the packets and information flow. That was a philosophy that meant to assure that if any part of the network were damaged, the rest of it would survive. They did not want what they considered at that time to be a single point of failure. Now, however, with advances in distributed computing and software engineering, we know we can have a logically centralized control plane in software that is reliable. We do it every day in places like major enterprises, banks, your transportation systems, the airlines, Yahoo, Facebook, and Google. In the world of networking, we've been in a habit for many decades of solving every problem with a new protocol between these autonomous systems. Every protocol is special purpose. It's a Band-Aid for one kind of a cut. But because we can now control networks through open software on ordinary servers, these control functions don't have to be protocols between devices. They can be software running above an API, and you can change it at any time. These are taking networking into the realm of computing, and we will see more evidence of that in a few slides. We believe these are the essential components of software-defined networking. The separation of the data plane, where the packets are forwarded, from the control plane, which determines how they are forwarded. Today, these are bundled together in proprietary systems. We will separate them logically and physically. By having centralized control software with a global view of the network, we can make better and more custom decisions for how traffic is routed in networks. In the data centers, we already have the global view. We predetermine the topology. We don't need the networking boxes to discover the topology themselves. And finally, with control in one place logically, it's very easy to have an application programming interface that allows consistent system-wide programming of the network for specific business purposes. This is a very general architecture view of software-defined networking. We separate it into these three levels or tiers. Starting at the bottom, the forwarding plane is the data plane tier. These are the switches that receive and forward packets. But that's all they do. They are no longer responsible for figuring out how to forward the packets. The control plane software that used to be present in every switch is now logically centralized in a server. It determines what the routes are, and it conveys it to the switches. I've shown both virtual and real, both software and hardware switches. Above the control plane, we have the applications. These are network control applications. This is where corporate or government or service provider policy is applied. I've only listed these here: security, traffic engineering, privacy, compliance with government mandate. Many examples. These are software routines that influence how the routes are chosen through the network, and they can be very specific to individuals. It is the specific programmability that will enable you to bring your own device to work, get full access to the services you need, and not take down the network. Here's the same picture, but with a different purpose. The control plane is in a different location from the switches, but they have to communicate. The control plane tells the switches what they should do when the packets come in. If you see a packet that looks like this, take this action. The switches don't know why, and they don't care. But the control plane software has to convey this to the switches. In return, the switches convey to the control what's happening in the network. They keep statistics. They let the control know if links are up or down. To convey this information back and forth remotely, you need what's called a protocol. The standard protocol to do this is OpenFlow. The Open Networking Foundation is the home of OpenFlow, and we are standardizing it. Once you have the ability to convey the path information to the switches, then you face the question of how do you determine what that path should be? And that's the upper half of the picture. And these are programming interfaces, often running in the same server. We are now exploring these, but we are not rushing forward to standardize them, because committees typically don't standardize programming interfaces. That typically comes from the market through open source or popular proprietary solutions that are easily changed. As networking becomes more of a computing discipline, we will follow the world of software and change our habit of standardizing everything we touch. Some elements of software-defined networking don't need to be standardized, at least not too soon. But this is the whole world of SDN, and you can see that the OpenFlow protocol is an enabler of the custom software that serves business objectives. I will now tell you something about the Open Networking Foundation. We are very young. We publicly launched 1 year and 3 months ago. The work on OpenFlow emerged from an academic environment in California. The research program was exploring how to design the future internet. They invited industrial participants. The industrial participants got very interested in what they were doing. graduate students began to graduate and start companies. And companies invested in the research program and participated in drafting the first versions of the OpenFlow protocol. One of these innovators is in the room with us today, Dr. Guido Appenzeller. I would like to invite him to the stage to speak about his experience in bringing this out of research and into the commercial world. Please welcome Guido Appenzeller.
じゃあ、プツさん、ありがとうございます。2008年から2010年まで、シリコンバレーのスタンフォード大学でオープンフローの開発が行われました。実は標準化に向けた開発に貢献してくださって日本の方々がいらっしゃいます。こちらの皆様は日本からオープンフローの開発に参画しました。まずは小林正義さんです。スタンフォードでオープンフローの生産開発とオープンフローのデモンストレーションに携わっていただきました。原美久さんです。オープンフロー 0.9 と 1.0 のインポリのコアな部分を開発していただきました。それで、達也矢部さんです。矢部さんはオープンフローチームで FPGA のインプルとテストスイートが作りました。もう皆様もお分かりの通り、初期のオープンフローの開発はまさに日本とシリコンバレーの共同プロジェクトだったのです。スタンフォードでのオープンフローの開発のシンプルな開発サイクルに従っていました。大抵の場合は次の標準化リリースに入れたい機能のリストを作成するところから始めました。次にこれから新しい機能が主なネットワーク機器ベンダーのハードウェアで動作するかどうかの検証をしました。NEC、シスコ、ジュニパー、HP が我々に協力してくれました。もし彼らから良いフィードバックが得られた場合、スタンフォードのエンジニアリングチームと一緒に新しい機能のレフェレンス実装を作りました。このレフェレンス実装はプロダクション開発の一部として採用されます。そして数週間かけてこの新しいリリースのパフォーマンステストを行います。プロダクションな開発に必要な機能と基礎のハードウェアへのインプリを簡単にする今ご紹介した1割のプロセスこそが今のオープンフローを支えているのです。ありがとうございます。
Arigato, Guido-san. After 3 years, there was such strong industry interest, they decided to form a new organization to take this into the commercial world through standards that they, as users and operators of networks, could control, and they formed the Open Networking Foundation. We took this draft standard from this ad hoc group of students and industrial engineers and we've taken it to make it industrial strength. Already in our first year, we've added important features such as support for IPv6, extensibility, configuration, and interoperability. We are moving quickly to meet the needs of the market. We are deliberately trying to run our organization like a Silicon Valley startup company to meet the needs of our customers. You can find this information on our website. The Open Networking Foundation makes standards such as OpenFlow, but we are not only a standards development organization. Our goal in life is to see this become a commercial success for the benefit of network operators and users. We believe that it won't be long before people think about SDN as the only sensible way to run a network. We will all look back and think, how did we do it the other way for so long? We measure our success by the vibrancy of the market, not by how many standards documents we produce. And as an operating unit, we are driven and controlled by the user community with the cooperation of vendors, but not the control of the vendors. This is our board of directors. You will see that we have 4 major data center operators and 3 global powerhouses of telecom operators. We also have the 2 founding professors that have guided this work since its infancy. You can see that the representatives of these companies are very high-level executives, which shows how important this activity is for their companies. And I'm very pleased that one of our board members is in the room today. I would like to invite Mr. Yukio Ito, Senior Vice President of NTT Communications, to join me on stage. Please welcome Ito-san.
日本語で話しますのでご安心ください。今ご紹介いただいた NTT Communications の伊藤です。この表にありますように、ONF の運営はたくさんいろんなベンダーさんだとか大学だとかこういう事業者ですね、サービスプロバイダーとか入ってるんですけども、ボードメンバーはですね、ベンダーさん以外で構成されています。そういうことでこのボードメンバーの中でいろんなプロトコルのですね、技術の新しい提案だとかいろんな検証の結果だとか、あるいはその組織としてこのファンデーションを運営してますので、その運営に関するですね、いろんな議論をしています。で、私NTT グループ全体でですね、いろいろなところで実はこの SDN に関わっております。実は手前味噌で恐縮ですけれども、月曜日に私どもも新しいエンタープライズクラウドというものを発表させていただきまして、その中でもちろん仮想化コンピューターの仮想化技術ももちろんですけれども、合わせて今回オープンフローを使った形でですね、仮想ネットワークの技術も同様に提供するということを発表させていただいております。また、持ち株会社や NTT データさんをはじめですね、今週いろんなプレスリリースが出ておりますけれども、実は私このボードメンバーで入っております関係もあるんですが、 NTT グループ全体の中でですね、こういう、アクティビティがどうなっているかというのを共有しながら進んでいるところでございます。で、先ほどからダンさんの話にもありましたように、あんまり固いこの標準化というよりはいろいろな技術をやってですね、どちらかというと教科書的なことをどんどん早く決めていこうということでこの活動はされております。ONF の活動ですね。それで先ほどご紹介がありましたように、NEC の方々はじめですね、たくさんの日本人の方々がですね、この活動に実は参画しております。 ちょっと一例でご紹介いたしますと、これは皆さん検索すればいろいろと発見できますけれども、NTT グループの取り組みはもちろんでございますが、NEC さんがその製品としてはハードウェアスイッチを世界で初めて発表したとかですね、あるいはそのプロトコルの関係でいろいろなその、コントローラーの技術開発だとか、そういうことをやっているミドクラさんだとか、トラストスフィアさんだとか、その他にもですね、いろいろなですね取り組みがここにあるように実行されています。そういうことでですね、たくさんの日本の方々が開発に関わったり、あるいは実際に使われたりしているわけでございます。ということで今回のこのプレゼンの表題にありますようにまさにですね、この SDN オープンフローに関しては世界の中でもですね、具体的な取り組みが一番進んでいるのがひょっとすると日本かもしれないというふうに私も思っております。で先ほど申しましたようにいろんなディスカッションをやってる中におきまして、皆さんもですね、いろんな形で参画できると思っております。そういうことで、まさにあまり従来でいう悪口を言うわけじゃありませんけども、ベンダーさん主導で決めていたような話ではなくて、利用者サイドからのですねいろんな要望を含めて議論ができるような環境だと思っております。ということで、いろんなですね提案が可能だと思いますので、ぜひですね日本から世界を変えていくということでですね、皆さんと一緒に取り組めればいいと思います。そのために、私もボードメンバーの一人としてですね少しでもお役に立てればと思っております。以上です。ありがとうございました。
Thank you, Ito-san. We launched publicly March 21st, 2011, with 23 members. We have more than tripled our size. And look how many Japanese members we have that are playing leading roles in this movement. Notice also how widely represented the entire industry is. We have chip vendors, system vendors, all the major system vendors, software companies, the 4 major computer companies, because networking is now part of computing, many other operators, small startup companies, global leading gigantic companies. All are members of the Open Networking Foundation. We are building a community of enthusiasts for this revolution in networking. We had a meetup on Monday for our members and prospective members in Tokyo. We had 19 of our member companies and 11 other companies interested in becoming part of this movement. These are the activities we engage in. We do create standards, but we standardize as little as necessary, not as much as possible. We do not want to constrain the innovation that is happening, especially in software. We work on architecture and the fundamental abstractions. We study interfaces and how to enable service providers to offer services based on this technology. But we are not rushing into standardizing these things yet. We have an important market education effort. Many people are interested in software-defined networking, but don't know exactly what it is. As engineers, we are guilty of talking about the technology a lot. In this activity, we talk about the benefits of the technology instead. We also have a particularly well-chosen policy on intellectual property that makes it easy for companies to join, it makes it easy for us to move quickly, and it keeps the lawyers out of the picture. You can find all this information on our website, so I will not test you on it today. We have many activities with much participation. We have outstanding leaders of all of the groups. Even if they come from the vendors, they are appointed by the board, and they are held accountable by the board with deliverables and deadlines. These are the marching orders I have from the board of directors. We continue to improve the technology to meet market needs. In particular, OpenFlow today applies only to Ethernet Layer 2 networks. We are going to use OpenFlow to control optical networks, circuits, and wireless networks. There are many opportunities to enhance network security and corporate security using OpenFlow and SDN. We will explore that. We already have 2 versions, one version and an upgrade of our switch configuration protocol. We will continue to enhance that to ease management and operations. We are developing conformance test suites and interoperability testing events so that customers can be assured that if they buy an OpenFlow product, it will implement the standard and it will work with other vendors' equipment. We are doing whatever we can to foster and enable implementation of the standards we produce. We query and ask every participating company who is contributing to the working group standard, do you plan to implement this? And if not, why not? We are trying to build the tools that help them implement quickly. And finally, we are evangelizing the story so that people understand it. They understand its importance and what it can do for them. This is not just the latest new protocol in networking. This is a change to the field of networking as we know it. It will become part of computing. It won't be the problem for IT managers it has been. They will be able to manage networks in a consistent way with managing virtual machines and applications. In enterprises, the software people will be programmers, not plumbers. Think about your role in your company. How will you move this forward? Network operators are rapidly evolving to become expert in software and service management. Those that don't will find the software opportunities taken by faster-moving companies, and they will be relegated to bit transport. The competition for the best control software will bring many benefits to enterprises and eventually to consumers. The IT shops in enterprises will finally be able to directly respond to business needs by programming the network in accordance with the business need, under their control, finally. It's been about 12 years since we saw many networking startup companies. And in those days, they were all switch fabric companies. They required venture investment of $150 million to reach a liquidity event. Networking will start to look like Web 2.0 software companies. Build a control app. Find a need that has not been met. There are many. And we'll have networking software startups. Guido-san is CEO of one of them. We will have networking apps. If you want to write one, you will be able to. This will not look like the networking we've known for 40 years. But people will appreciate what networking does more than they ever have before. Software-defined networking is a major change, one that comes about once in a generation. Open flow is the cornerstone, without which you do not get the benefits of the logically centralized control plane and the ease of programmability by direct application. The industry has demonstrated that they are investing in a major way in these technologies. This is a commercial reality. If you have any doubts, come to the show floor. In the OpenFlow showcase alone, there are 7 use cases. You could think of your own after you're there for about 20 minutes. The Open Networking Foundation feels a great responsibility to the networking world to bring this future about. We could not do it without our partners in Japan. It is a cause worth pursuing. We are proud to have that responsibility. I look forward to hearing about your contributions as well. I thank you for your kind attention.
皆様、ご清聴ありがとうございました。以上をもちまして、インターロップ東京2012基調講演K6を終了とさせていただきます。